We started quadratics today. We talked about the different transformations a quadratic has. I need to show you a couple more things, some vocabulary things, some formula things, and then we actually need to get to some problems. Okay? So first of all, it's asking us to fill in this table. Use a calculator to generate the table of values for this function. Okay? So I'm going to go to my calculator, and I'm going to go to my new documents. I want to make, that's not what I want, a new document. Go away. Go away. I want a new document that's a graph. Okay? And in my graph, I want to put in this equation. X minus 3 squared plus 4. Yeah, that's a nice and pretty graph. I don't care about the graph. What do I care about?
The numbers.
The table. How do I get the table to come up?
Hit Control T.
Control T, excellent. So here's my table. So let's fill in the table. 1 is 12, 2 is 6, 3 is 4, 4 is 6, 5 is 12, and 6 is 22. Okay? Now, simplify the function using squaring, distributing, and collecting like terms. What does it mean to have x minus 3 squared? Anything squared is that times itself, right? So we have x minus 3 times x minus 3. This is the stuff we just finished last chapter, right? So we know we have to distribute. X times x is x squared. X times 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Okay? I'm going to zoom in just a little bit. Maybe that'll help. Is that better? Now if I combine my like terms, I have x squared. Negative 3x and negative 3x is what? Good. Negative 6x plus 9. Then I have everything multiplied by that 2 out there. Okay? So I have 2x squared minus 12x plus 18, and then we still have that 4 we've been dragging along this whole time. So on our last step, I need to add the 18 and the 4. Y equals 2x squared minus 12x plus 22. What would happen if I put that into a new, I'm going to make my table go away for just a second, Control T. What would happen if I hit tab and put a new equation into my calculator? That was that equation I just figured out.
The table would be the same.
Why do you think the table would be the same?
Did you just shorten the problem?
Because you think I shortened the problem?
Maybe.
Control T. Are they the same?
Yeah.
So did I shorten the problem or did I simplify the problem?
Simplified it.
Okay, but are they the same thing?
Yeah.
In fact, both of these equations are examples of what kind of functions?
Quadratic.
Oh, quadratic. That was so excellent. Yes, I was being sarcastic. Just a little bit. Okay? There's 2 forms of these functions that I need you to know. You already know one of them, or at least you've seen one of them, because we talked about it when we were factoring. You remember that? Because we had to find A, B, and C to find A, C, and B and stuff, and junk and stuff. There's also another form called Vertex Form, and you might like this form, and if you do, that's great. But when you see how Vertex Form can be used today, you're going to like it a lot more, especially when we're graphing. Okay? Y equals A times x minus h squared plus k. I think it's funny that they make me write it for you, and then they already wrote it right here. But whatever, they don't ask me. Okay?
I asked you.
All of these transformation effects, see, transformation effects, we just figured those out, didn't we?
Yeah.
On the previous worksheet? This one? We just figured all those out, didn't we?
Mm-hmm.
Okay? This is important. Maybe some stars, maybe a flower, maybe the sun to shine to make the flower grow.
Can you draw a flower on my paper?
Maybe like a rain.
Can you draw a flower on my
See, this is why I wouldn't be good in prison. I can't draw raindrops. They look like Hershey's Kisses.
That's nice.
So just people in prison are the only one who gets teardrops on their eyes?
Maybe they're not in
Little
prison.
Wayne.
They haven't been caught yet, but I don't know.
So if I get one, you're automatically going to put me underneath of it. Going to jail or already in jail.
Yes. You know what they mean, right?
How many times they served that?
I thought it was
No, that's something like
Isn't it the game though?
Sometimes it's how many people they've killed. Okay. Not that we need to talk about that in math class when we're recording the lesson.
Oh,
Yes.
shoot. I'm trying to disappear.
Will they call us out
You can
for
edit
the blood test?
No.
Okay, can I go then?
Okay, so here's some sample problems. I know sometimes several of you need to be really linear. You need to do 1, then A, B, C, D, E, and F, and then 2, A, B, C, D, E, and F, and then 3, A, B, C, D, E, and F. That's not how we're going to do these today because it's not the easiest way. Okay? You know I like to do things the easiest way because you guys like to do things the easiest way, right? Okay? So here we go. First thing it asks is to state if there's a reflection over the x-axis.
No.
What causes a reflection over the x-axis? Look back at your notes from the previous worksheet if you need to. What causes a reflection over the x-axis? A negative in the front, right? As a multiplier. Do any of these problems have a negative in front as a multiplier?
No.
Number 2 does. Yes.
Yeah.
So what about 1, 3, and 4?
No.
No. No. No. State if there's, identify any vertical shift. What causes a vertical shift? Vertical shift.
Isn't it if it's under point? No, it's not.
If there's a number being added or subtracted outside of the squared. Do any of these have vertical shifts?
Yeah, 1 and dose. No, 1 dose and 3, that's it.
So 4 does not. So for B, we're going to put no. What are we going to put on B for 1? It does have a vertical shift. Where does it shift?
Up 4.
Up 4.
Oh.
Can you not see it very well? Let me zoom out a little bit. Is that better? Okay. Does 2 have a vertical shift? Where?
Yeah, down 5.
Down 5. Does 3 have a vertical shift?
No.
Down 4.
Oh, shoot, I was looking at 4.
Okay. The next thing is C. Identify any horizontal shift. Is there a horizontal shift in any of these?
No.
What
Yeah.
causes a horizontal shift? If there's something inside the parentheses being added or subtracted, right? So which ones of these have horizontal shifts? All of them. Okay. So where does 1 move? Right 2. Where does 2 shift?
Right.
Right 4. Where does 3 shift?
Left 3.
Left 3. And 4?
Left 5.
Left 5. Next thing. Identify any vertical stretch or compression and by what factor.
Yeah, the only one with that is 34.
Vertical stretch or compression has a multiplier. So the only thing with the vertical stretch or compression is 3 and 4. Very good. So what are we going to write on 1 and 2? No. No.
So, yeah.
So we're not going to just write yes. We're going to write what it is and what the compression is or stretch is, right?
It's a stretch.
2 is a stretch because it's greater than 1. So we're going to write a stretch
And then,
by a factor of 2.
the other one is a compression.
Compression by factor of a half, right? That's the multiplier, so that's the factor. Okay? Letter E says determine the standard form of the quadratic equation. Unfortunately, I don't have time to show you any of those. Okay? But it's just like this problem that we did at the very beginning. This is putting it into standard form. Can you tell that it was in vertex form? And you do all your multiplication and simplification to get it into standard form. Okay? So look back at this if you need help for there. The last thing is to sketch a graph.
Oh, I got this.
Except if you've told yourself everywhere it moves, sketching a graph is not hard, is it? Okay?
Yeah.
It moves up 4 and right 2. Up 4 and right 2. That's the new vertex, isn't it?
Yeah.
Is there a stretch or compression? Then it's the same shape that it was before, isn't it? If it's the same shape it was before, look what happens. If I went over 1, I went up 1, because 1 squared, that's the parent function, right? 1 squared is 1. If I went over 2, I went up how much? 4, because 2 squared is 4. If I went over 3, how much did I go up? 9, because 3 squared is 9. If this is my new vertex, the cool part about this, when there's no stretch or compression, I don't have to care about what points it goes through. I just have to know it went over 1, up 1, over 2 from the vertex, up 4, and over 3, up 9, but that puts me up there somewhere. I also know parabolas are symmetric, and there is my parabola. Okay?
My sketch looks really like that.
Jump over please to 5 and 6. I really wanted to graph number 4 for you because it's a little bit different, but you're going to have to just try that on your own. Look at 5 and 6. When we're writing equations, see, it's backwards, isn't it? Here it gives us the equation and wants the graph. Here it gives us the graph and wants the equation. When we're writing equations like this, it's so much easier if we use vertex form. Because remember down at the bottom where we put the stars and the flower?
Miss Kingston,
Yes?
I need TJ Smart to come to the office just for a second.
He's on his way.
Thank you.
I know my vertex is HK. Okay? If I know my vertex is HK, 1, 2, 3, 1, 2, 3, 4, 5, that point is 3, 5, which is HK. Look, all I have to do is fill in H and K. Y equals x minus 3 squared plus 5. All I have to do is figure out if there's an A. Is it parent function shape? Does it go 1, 1, 2, 4, 3, 9? Yes?
Yeah.
Then it's parent function shape and there's no number. However, the parabola is upside down. What causes it to be upside down?
Negative.
Negative.
Number. Oh my God.
Done.
Look at me.
You can put a -1 if you want, or you can just leave the negative. Do we have time for the other one?
It's 50.
Let's try.
This one's easy.
Where's the vertex?
1, 2, 3, 4, 5, 4.
-5, -4.
Negative 5,
So that's
4.
HK. Y equals x plus 5 squared minus 4, because it would be minus a -5, right? So I can know that that's plus 5. I have to figure out if it's parent function shape.
So,
Does it go 1, 1, 2, 4, 3, 9?
yeah. No.
It doesn't this time, does it? It goes 2. It only goes half as high. Guess what A is?
It's
Half.
half.
Have an awesome day. I'm sorry I took extra time today. I'll give it back to you later. Have a great day. Peace.